80% of engineers need to reskill. Over 100 AI tools exist, but only 3 skills actually matter. I analyzed 500 job postings to find them. Right now, there is a specific type of anxiety spreading through the tech industry. You open LinkedIn, and it feels like everyone became an AI expert overnight. You see the headlines about new models writing code faster than you can think. You might be asking yourself the uncomfortable question: is my experience becoming worthless? Am I falling behind? The noise is absolutely deafening. Every morning, there is a new framework, a new vector database, or a new agentic workflow that you supposedly must know or risk becoming obsolete. But here is the truth that cuts through the hype: you do not need to learn everything. Trying to master every new tool is actually a trap. It is the fastest way to burn out without actually increasing your market value. I dug into the real data. I compared standard senior software engineer roles against the new wave of AI engineer roles. The salary gap is real, and it is widening fast, sometimes by as much as $100,000 for the exact same years of experience. But when you strip away the buzzwords and look at what hiring managers are actually testing for, it isn't obscure math, it isn't a PhD in neuroscience. It comes down to just 3 specific practical competencies. These 3 skills are creating 90% of that salary premium. If you are a developer, a QA engineer, or a tech lead, you already have the foundation. You don't need to restart your career, you just need to re engineer it. In this video, I am going to show you exactly what these skills are, backed by market data, not hype. We aren't just talking theory, we are building your survival guide. By the end of this video, you will have a complete, realistic 90-day learning plan to add AI engineer to your title this year. Let's look at the numbers. The numbers tell a story that is both terrifying and incredibly opportunistic. According to recent market analysis from major hiring platforms, the demand for AI specific roles has grown by over 400% in just the last 18 months. But that is just the headline. When you look closer at the data, you see a silent crisis unfolding in the traditional software engineering market. We are seeing a divergence in career trajectories that looks like the letter K. On the upper arm of the K, you have engineers who have successfully integrated AI competencies into their workflow. Their salaries are climbing, often breaking the $300,000 mark for senior individual contributor roles. On the lower arm of the K, you have traditional code first developers. Their salaries are stagnating. The number of entry level and mid level roles available to them is actually shrinking. This creates a very specific, painful situation for many of you. Imagine a senior developer named Alex. Alex has 10 years of experience. He knows Java and Python inside out. He understands distributed systems. He has survived the migration from on-premise servers to the cloud. But lately, Alex feels like a junior again. He sits in meetings where product managers are throwing around terms like context windows, retrieval augmented generation, and agentic loops. He nods along, but deep down, he feels a pit in his stomach. He knows he is missing something fundamental. So, Alex does what any good engineer would do. He tries to learn, he goes home on the weekend and opens YouTube. He sees a tutorial on LangChain. He spends 10 hours building a chatbot. But by the next week, a new library has come out that makes his weekend project obsolete. Then OpenAI releases a new model that changes the API structure entirely. It feels like trying to build a house on quicksand. This is what we call tutorial hell. But in the AI era, it is much worse because the ground is moving faster than you can walk. The problem isn't that Alex isn't smart. The problem is that the definition of value in software engineering is shifting right under his feet. For the last 20 years, your value as an engineer was largely defined by your ability to translate human logic into machine syntax. You were the translator. You knew the language of the machine. But here is the hard reality check. AI is now an infinite, low-cost translator. Tools like GitHub Copilot and Claude are rapidly driving the cost of syntax generation to zero. If your primary skill is knowing how to write a function in React or how to configure a SQL query, you are competing against a machine that can do it faster, cheaper, and increasingly with fewer errors. This is why we see the panic. It is not just about learning a new tool. It is the realization that the moat you built around your career, your knowledge of syntax and libraries, is drying up. The barrier to entry for coding is lowering, which means the supply of people who can write code is about to explode. Basic coding is becoming a commodity. However, and this is the crucial pivot point, While the value of syntax is dropping, the value of system design and problem formulation is skyrocketing. The engineers who are getting hired for those high paying AI roles are not necessarily better coders, they are better architects. They understand how to stitch these probabilistic AI models into deterministic business applications. Consider the consequences of ignoring this shift. It is not that you will walk into work tomorrow and a robot will be sitting at your desk. It is much more subtle. It starts with being passed over for the interesting projects. Then it is noticing that the new hires, who might have 5 years less experience than you, are being consulted on architectural decisions because they understand how to leverage large language models. Eventually, it leads to a career plateau where you are maintaining legacy systems while the rest of the industry moves on. But the anxiety you are feeling, it is actually a signal. It is telling you that you are ready to move up the stack. The before state is you, overwhelmed by 100 different tools, trying to memorize APIs. The after state we are aiming for is you, understanding the fundamental principles that don't change, regardless of which model is trendy this week. If you want to make that shift from the before state to the after state, make sure you subscribe to this channel right now. We are dedicated entirely to helping you navigate this career shift without the hype and without the burnout. We are building this roadmap together. We need to stop looking at AI as just another library to import, like a new testing framework. We need to start looking at it as a new computing paradigm. Just as the industry shifted from desktop to mobile or from on prem to cloud, this is a structural shift. The engineers who survived those previous shifts didn't do it by panicking. They did it by identifying the core skills that transferred over and the new skills that actually mattered. You don't need to become a machine learning researcher. You don't need a PhD in math. You need to understand how to engineer systems where the CPU is probabilistic, not deterministic. That is the core of the problem, and that is exactly what we are going to solve. We are going to strip away the noise of the tool of the week and focus on the three enduring skills that will secure your position on the upper arm of that K-shaped recovery. The solution to this career anxiety begins with a definition because most people are aiming at the wrong target. When you hear AI engineer, you might imagine a researcher at Google DeepMind writing complex mathematical proofs or designing new neural network architectures from scratch. Let me be very clear. That is not the job we are talking about. That is AI research. That path requires a PhD and a decade of academic focus. The opportunity for you, the software engineer, the product manager, the technical lead, is in AI application engineering. This is the sweet spot. This is where the massive demand lies. Companies do not need more people to build the engines. They need people who know how to put those engines into cars, trucks, and airplanes to solve actual business problems. They need architects who can take these raw, powerful, and somewhat chaotic intelligence models and constrain them into reliable, useful software products. To do this, you don't need to relearn calculus, but you do need to master a new mental framework. We call this the AI engineering triangle. Visualize a triangle in your mind. This is your new career map. At the top point of the triangle, we have cognitive architecture. This is not just writing prompts. This is understanding how to chain multiple AI steps together to perform complex reasoning. It is about deciding when to use a simple model, when to use a complex one, and how to structure the thought process of the application. At the bottom right corner, we have context engineering. This is the data layer. An AI model without your company's data is just a generic chatbot. Context engineering is the art of feeding the right information to the model at the right time. This is where concepts like RAG, Retrieval Augmented Generation, and vector databases live. It is about giving the brain a memory. And at the bottom left corner, the piece that almost everyone ignores is AI reliability. In traditional software, if you write a test, it passes or it fails. It is binary. In AI, the output is probabilistic. It might work 90% of the time. How do you build a system that is robust enough for production when the underlying component is unpredictable? This is the skill of evaluations and observability. This triangle: architecture, context, and reliability. This is the solution. It is the framework that separates the tutorial watchers from the high paid professionals. Now, I want to address the biggest mental block you are likely facing right now. It is the shift from deterministic thinking to probabilistic thinking. As engineers, we are trained to love certainty. Input A plus input B must always equal output C. If it doesn't, it is a bug. We fix it. But in this new world, you are working with components that are creative, non deterministic, and occasionally hallucinate. This feels wrong. It feels like chaos. But the solution isn't to force the AI to be a calculator. The solution is to become an engineer of probability. You are no longer just writing instructions. You are managing outcomes. You are building guardrails. You are the conductor of an orchestra where the musicians sometimes improvise. This shift is actually good news for you. Why? Because building these systems requires deep software engineering knowledge. A junior developer can write a prompt, but only a seasoned engineer understands latency, caching, security, and system integration. Think about it this way: the AI model is just a new type of CPU. It is a CPU that understands English but is slow and sometimes lies. Your job is to build a reliable computer around this strange new CPU. If you are a backend engineer, you already know how to move data. Context engineering is just a new way of querying a database. If you are a front end engineer, you understand user intent. Cognitive architecture is just mapping that intent to system actions. If you are in QA, you understand edge cases. AI reliability is the ultimate QA challenge. You are not starting from zero. You are taking your existing 10 years of experience and upgrading the engine. You are moving from the code stack to the AI stack. So let's stop worrying about which specific tool to learn today. Tools change every week, patterns stay the same. Let's dive into the first corner of our AI engineering triangle: cognitive architecture. If you have been using ChatGPT or Claude just to ask questions and get answers, you are only scratching the surface. That is what we call a zero shot interaction. It is like walking up to a stranger and asking for a complex business analysis immediately. You might get a decent answer, but it will likely be shallow or hallucinated. Cognitive architecture is the art of breaking that interaction down. It is the shift from building chatbots to building agents. Imagine a flowchart in your mind. In a traditional chatbot, the user sends a message, the AI processes it, and sends a reply. It is a straight line: input, process, output. Now visualize a loop. In an agentic workflow, the user sends a request, say, plan a business trip to London. The AI doesn't just guess, it enters a reasoning loop. First, it thinks, I need to know the dates. It asks the user. Then it thinks, I need to check flight prices. It calls a tool, an API, to search Expedia. It gets the data back. Then it thinks, I need to check the company travel policy. It retrieves a document. Finally, it synthesizes all this into a response. This is often called the react pattern: reasoning plus acting. As an engineer, your job isn't to write the response. Your job is to design that flowchart. You are defining the tools the AI can use, the permissions it has, and the logic it follows when it gets stuck. You are not coding the answer, you are coding the process of finding the answer. Think of it like hiring a brilliant but inexperienced intern. If you tell them, fix the database, they will panic. But if you give them a checklist: first, check the logs. Second, identify the error code. Third, look up the documentation. They can execute complex tasks perfectly. Cognitive architecture is simply writing that checklist for the model. This is why software engineering skills are so vital here. You are dealing with state management. You have to track the conversation history. You have to handle errors when the flight API goes down. You have to ensure the agent doesn't get stuck in an infinite loop of checking prices. The model provides the intelligence, but you provide the structure. Now let's move to the second corner of the triangle, and arguably the most critical for businesses right now: context engineering. Here is the problem every company faces. They want to use AI, but the AI doesn't know their secrets. ChatGPT knows who the president is, but it doesn't know your Q3 sales data, your internal HR policies, or the specific way your legacy codebase handles authentication. You might think, I will just paste the documents into the chat. That works for a PDF or two. But what if you have 10,000 PDFs? What if you have a terabyte of customer logs? You cannot fit that into the prompt. This brings us to the most in demand architectural pattern of 2026: RAG, or Retrieval Augmented Generation. Let's use an analogy. Imagine you are taking a final exam. A standard LLM is like a student taking the test from memory. They might be a genius, but if they haven't memorized the specific textbook, they will fail, or worse, make things up to sound smart. Context engineering turns that into an open book exam. Here is how it works visually. Picture a massive library containing every document your company has ever written. When a user asks a question, we don't send it to the AI yet. First, we send a librarian, a search algorithm, into the library. The librarian sprints through the aisles and grabs the three specific pages that contain the answer. We take those three pages, staple them to the user's question, and then hand it to the AI. We say to the model, using only these three pages, answer the question. Suddenly, the hallucination rate drops near zero. The AI isn't guessing, it is summarizing facts you provided, but there is a catch. How does the librarian find the right pages? Keywords aren't enough. If the user searches for revenue decline, but your documents only say sales drop, a keyword search fails. They are different words with the same meaning. This is where you need to understand embeddings. This is a core concept you must grasp. Visualize a 3D space like a galaxy of stars. Every document in your database is a single star. The magic of embeddings is that they arrange these stars based on meaning, not spelling. The document for revenue decline and the document for sales drop will be placed right next to each other in this galaxy because they mean the same thing. When you build a RAG system, you are essentially building a GPS for meaning. You are converting text into coordinates. Your job as an AI engineer is to optimize this retrieval. How do you chop up the documents? Do you split them by paragraph or by page? Do you include the document title? These are engineering decisions that drastically change the performance of the system. If you are a back-end engineer, this should feel familiar. You are essentially building a search engine. The database is different, it is a vector database, but the principles of latency, indexing, and data pipelines are exactly the same. You are the bridge between the company's raw data and the AI's reasoning capabilities. And speaking of building, we talked a lot about context engineering and RAG today, but knowing what it is isn't the same as knowing how to design it for production. In the next video, I am going to break down the exact architecture of a production-ready RAG system. We will visualize exactly how the data flows, where the bottlenecks are, and how to keep it cheap. You do not want to miss that, so make sure you are subscribed. This leads us to the final and most neglected corner of the triangle: AI reliability. This is the skill that separates the hobbyists from the professionals. It is easy to build a demo that works once. It is incredibly hard to build a system that works 10,000 times in a row without embarrassing the company. In traditional software, we have unit tests. Assert 2 plus 2 equals 4. It passes or it fails. It is binary. But how do you write a unit test for a summary? If you ask the AI to summarize this email and it produces a paragraph, how does your code know if it is a good summary? The words will be different every time. You can't just check string equality. If you try to deploy an AI feature without solving this, you are gambling. You are deploying a vibe-based product. And when the AI inevitably hallucinates and promises a customer a 90% discount that doesn't exist, you will be the one answering to the CTO. The solution is a concept called Evals or evaluations. Think of it like grading an essay. You don't look for exact word matches. You use a rubric. Did the student mention the main conflict? Is the grammar correct? Was the tone appropriate? As an AI engineer, you build automated graders. And here is the meta twist. You often use a stronger AI model to grade the weaker one. Imagine a pipeline. Your application uses a fast, cheap model to answer customer chats. In the background, you have a judge model, maybe GPT-4, watching those conversations. The judge has a scorecard. Did the answer stay polite? Did it cite the correct policy? Did it hallucinate? You run this over 1,000 test cases. You don't get a pass or fail, you get a percentage. Our current system is 92% accurate on refund questions, but only 65% accurate on technical support. Now you are doing real engineering again. You have metrics. When you tweak the prompt or change the retrieval strategy, you can see if the numbers go up or down. You stop guessing and start optimizing. This is where the QA mindset is incredibly valuable. If you come from a testing background, you are already ahead. You understand edge cases. You know that users will try to break the system. The tools are different, but the discipline is the same. So, let's look at the full picture. Cognitive architecture is the brain, how the system thinks and uses tools. Context engineering is the memory, how the system accesses the right information. AI reliability is the conscience, how we ensure the system behaves correctly. Notice what is missing from this list. I didn't say Python syntax mastery or knowing how to configure Webpack. Those are implementation details. The value you provide is in designing the architecture, the data flow, and the evaluation rig. The shift is from writing the code that does the work to writing the code that orchestrates the intelligence. If you can master these three domains, you become the most valuable person in the engineering room. You become the person who can look at a vague business problem, like we need to automate support, and actually deliver a reliable working system, not just a toy demo. But knowing the concepts is only step one. You need a plan to learn them. You need to know which specific libraries to touch, which projects to build, and how to structure your weekends so you don't burn out. Now you understand the what: architecture, context, and reliability. But understanding the theory won't get you the job offer. You need a specific execution plan. Most engineers fail here because they try to learn everything at once. They download PyTorch, try to read research papers on transformers, get overwhelmed by the math, and quit. We are going to avoid that trap. We are going to structure your transition into a realistic 90-day sprint. This is designed for someone working a full time job. You don't need to quit, you just need to be disciplined with your evenings and weekends. Month 1 is the foundation. Your goal here is to master the API layer. Do not worry about vector databases or complex agents yet. Focus entirely on understanding how to talk to these models programmatically. Learn the difference between system prompts and user prompts. Understand parameters like temperature and top P. Your deliverable for month 1 should be a simple command line tool that wraps an LLM to perform a specific utility, like summarizing your Git commits or generating unit tests for your existing code. Month 2 is the builder phase. This is where we tackle context engineering. You need to get hands on with RAG. Pick a vector database. It doesn't matter which one, just pick the standard industry option like Pinecone or VV8 or even pgvector if you like Postgres. Build a system that can read a specific set of documents and answer questions about them. The goal isn't the chatbot interface, the goal is understanding the data pipeline. Experiment with chunking. How does splitting the text by paragraph versus by sentence change the answers? This experimentation is where the real learning happens. Month 3 is the architect phase. This is where you build your portfolio piece, the Capstone project. You are going to build an agent. Do not just make a chat interface. Build something that takes action. Build an agent that can search the web, scrape a specific page, and save the data to a file. This requires tool calling, the ability for the AI to trigger code functions. And crucially, you must add an evaluation step. Write a script that tests your agent against 10 different scenarios to see how often it fails. As you execute this plan, there are two massive pitfalls you must avoid. First, stop trying to train your own models. This is the most common mistake I see. Unless you are aiming for a research role at OpenAI, you do not need to know backpropagation calculus. You do not need to know how to construct a neural network from scratch. In 2026, that is like trying to build your own database engine before learning SQL. Focus on using the models, not building them. The value is in the application layer. Second, avoid tutorial hell. Do not watch 10 hours of video without writing a line of code. This is lethal. The only way to learn AI engineering is to wrestle with the unpredictability of the models. Watch one video, then build something slightly different. If the tutorial builds a recipe generator, you build a workout generator. Force your brain to adapt the pattern to a new context. Finally, the most important shift is your definition of done. In traditional engineering, done means the code compiles and passes tests. It is binary. In AI engineering, done means the system is useful despite being imperfect. You are moving from being a coder to a product engineer. You are solving the problem, not just writing the syntax. If you follow this roadmap, foundation, builder, architect, you won't just have a certificate, you will have a GitHub repository that proves you understand the three pillars we discussed: architecture, context, and reliability. That repository is your ticket to the interview. But there is one final piece to this puzzle. It is about the future. It is about understanding where this industry is actually going in the next 5 years and why your timing right now is actually perfect. We started this journey with a startling statistic: 80% of engineers need to reskill. At the beginning of this video, that might have sounded like a threat, but now I want you to see it for what it actually is: an invitation to the most significant upgrade cycle in the history of computing. The title software engineer is evolving, not disappearing. The engineer of 2020 was defined by how well they could write syntax. The engineer of 2026 will be defined by how well they can orchestrate intelligence. The tools have changed, but the mission remains exactly the same. You are still a problem solver. You are simply upgrading to tools that allow you to solve bigger, more complex problems than ever before. It is easy to feel like you are already too late. You see the headlines, the new startups, and the experts on social media, and you feel behind. But here is the reality: everyone is a beginner right now. The experts you admire, they likely started learning this 6 months ago. We are all standing at day one of this new era. The playing field has been leveled. The only difference between the people leading this industry and the people fearing it is that the leaders decided to start building. Imagine where you could be in 90 days. You can spend the next 3 months worrying about whether AI will replace you, or you can spend them following the roadmap we just laid out, becoming the person who builds the AI systems. The ceiling on what a single developer can create has just been lifted. One person, armed with these three skills: architecture, context, and reliability, can now build what used to take a team of 10. That person can be you. The future belongs to the builders. It is time to stop worrying and start engineering. I will see you in the next one.